So today we will be covering how to create a parametric walkway in Dynamo. Okay. So for this project, we will be starting it off in Revit with a base, like the path of the walkway, which first we will be finding in Revit. It will be better if you can mute. I think some disturbance is coming. Yeah. So let me just take a model line and draw a simple spline as a path, just to give us a base to use as for the walkway that we are going to make in Dynamo. Not this one, not curved like this, straight curve. Something like this. Yep. So here we have our spline. So what we'll do is go to Dynamo, new. So the first step over here is to bring the element from within Revit into Dynamo. So in order to do that, since we have only one element, we won't be using select by all categories or anything like that. We can manually select it. So what we'll do is we'll simply type in over here model element. So we get this option under selections, which is a select model elements option. And we also get one for elements. But since we will be selecting only one element in this case, we will select the model element option. Let me switch this to manual since we don't want to run it every time. Select, click on this, it will turn gray. Go to Revit, and you can see you can select this option. Now, if you come back to Revit, you can see it will record the element ID of that property. So if you run it, you can see I have the model curve. So this is the first step to getting the Revit element into Dynamo. But if you go to geometry view and say zoom to fit, you can see nothing has appeared in Dynamo yet. Like there are no elements in Dynamo because this is still a Revit element which we have only selected. We now need to convert this from a Revit curve into a Dynamo curve so that we can do further geometry manipulations on it. So if I type in here, not this one. Not this one. Not this one. What we want is a curve from element. Just 1 second. Let me just close it and check the name I have it over here. Element.curves. Okay. This one. So what this does is this extracts the curve from within the element. So now you can see if I switch to geometry view, the curve is there within Dynamo. So what this simply did is this converted the Revit element into a curve in Dynamo. So here we have a curve. Okay, so what we will be doing over here is we will be having a walkway which will follow along the path of the curve. So every curve that we have is divided into, like, it has a start point and the base point. Let me show you. I can query its start point and query its endpoint as well. Okay. So we have these 2 points, which you can see has appeared. Okay. But another way to work with curves instead of points or lengths between the points, instead of doing it like that, you can use the parameter of a point. So every curve is divided, like the start point is 1, sorry, the start point is 0 and the end point is 1. Okay, so if you use curve parameter, search is not working. Let me go from geometry only. Curves. Yeah. So if you input this curve over here, when you input the point, you get its parameter, which is 0 in case of the start point. And similarly, if you input the point over here and the curve over here, which is 1. So what we want to do is we want to divide the curve into a number of pieces at equal intervals, right? So what we can simply do is we can use the point at parameter instead of using, say, a length or anything like that, so that as the curve length changes, it will always divide as per that. So what we'll do over here is we will go into plane at parameter. My functions are not supporting me. So this one, plane at parameter. So what the plane at parameter takes is the plane at parameter takes a curve as an input, and then it takes a point. So if I input the point over here, so what it does simply is it creates a plane at the desired location, at the desired point, whichever we are specifying over here. The parameter which we are specifying over here. Let me create something with that plane to make it understandable. So if I go and select create a rectangle. Okay, so what I'm going to be doing is I'm going to be doing a single rectangle. This is a plane and the numbers just to visualize. You want to say 4,000. Yep. So let me enter a number. Yeah. So you can select it. See that it has created a rectangle at the end because I have inputted 1, because 1 is the end of the curve. And if I input 0, it will create it at this end. Similarly, if I enter, say, 0.5, it will create midway and say. So what it does is it has broken the curve into 1 to 0. So as many divisions as I want, I can have within this by specifying the parameter value. So if I specify 75, it will be one third way. Okay. And why we are growing via this plane route is the, you can see as the curve changes its direction, the rectangle that is getting created, the plane of that is also shifting. Okay. So if I type in 5 over here, you can see the orientation of the rectangle is different. And if I'm typing it 8 over here, sorry, point 0.8. Yep. Again, the orientation of it changing, and it will keep on changing till we go to either end. Say if I do it 1, it's again changes. So what this ensures is the position of the rectangle, like the direction it is facing, it is always moving along the shape of the curve, and it's not independent of it. Okay. So any questions till this point? If not, I would move on to the next part. Okay. So now our task, since we want to create a number of objects along the path, we would like to create a number of planes and then create a rectangle for each of those planes on it. Okay, so we will go back to using a range. So that we can get a list of numbers and instead of entering one. So as we know, a curve always has a parameter which will start with 0 by default. Like this is fixed, not by default. You cannot change it. The curve parameterization will always be from 0 to 1, and it will always end in 1. So if we want to have, say, 50 division within it, so we need to divide 1 by 15, and that has to be the step. So what we'll do is divide, double, and number slider, just so that I can specify the number of divisions I want over here. Just one second. Let me just specify the number of divisions approximately I want and increase it to say 20. Okay. So now if I run it, I will have a list of numbers starting from 0 all the way up to 1, because that is the extent of my curve parameters. Now instead of inputting this over here, let me input this. Run it again. Okay. So here again we have a lacing issue because this is taking it as one input and this is considering the shortest option, which is 1. Okay, so it just took the first item on it. Here we will again right click and change the lacing to the longest. Okay, because we wanted to match the longer list of the two inputs that the particular node is receiving, which is 1 in this case and 21 in this case. So now if we run it, yep. So now you can see it has created a number of rectangles as it moves along the curve. Okay, which was our intended goal. So yeah, we have all the rectangles over here. Now if we want to create a solid, what we can simply do is we can take the loft command from over here, and it takes a number of cross sections as inputs. Cross sections are nothing but simply closed curves. In this case, it being the 21 rectangles that we generated. If we plug it in, so now you have a kind of a tunnel or a walkway going through, following the profile of the curve that you have drawn. If you change the curve and run the script again, it will update the profile as it is. Okay. Okay, so this was still creating lofts, but we would like to make it a little more detailed, like have individual components for each of the rectangle. So we are going to focus on that. So Any questions till this point, like creating the loft or how we got there, changing the lacing and all that? Okay. So now we have the rectangles and we would like to add some volumes to the rectangle, like give it a shape, like say it's made out of wood or like a cylindrical profile, something like that, right? So what we'll do is we have each rectangle, we would want to create a sweep around it. So sweep is a form of 3D which goes around a surface. Okay, like it takes a curve and a path as input. Okay, so the curve is the profile. If I show you, so the curve will be a profile like a rectangle, and the sweep will be following the path, which will again be a set of curves. So over here, we will plug the curves in, which is the path for each rectangle. But we have a challenge to put the curve in, because if we simply draw a rectangle, it won't be placed at the correct position. Okay, it needs to be placed on each of the rectangles. So we will again go back and use the curve plane at parameter command, copy it in. Here we will use the rectangle as the curve, and the parameter we can use anything. It really doesn't matter because we just want a plane which is aligned with the position of the rectangles. And we will create a smaller rectangle over there. Mm, So again, so we are creating a third plane which is only lies on the rectangle itself. Okay. So that it's aligned with the curve of the rectangle. If I go into numbers, type into numbers, say 500. And you can see now, if I switch to a geometry view, that these small rectangles has been created at the correct positions, which is sitting along the plane of the curve. Okay, so that we can do a extrusion. If it was not sitting, if it was somewhere else, we would not be able to do it. So now that we have these rectangles, what we can do is we can plug them in. And now, as you can see, we have the rectangles created all as solids at every turning of the curve. Let me increase the number of divisions. 30. So yeah. So we have 34 solids over here, which is each of these objects. But normally we won't be having this on a totally circular thing. If I draw a ground plane right now, if I switch to node plane and say I was to introduce the ground plane to it right now, say rectangle, number, and put in something like say 6,000. I forward in the plane. Just a base plane centered on the origin and XYZ. Yeah. So this has become a little too big for me. Let me make this larger. Okay. So as soon as I make it 10,000, this gives an error, but I can see it has been generated. Okay, you can see the input lies outside the allowable modeling range, choosing a larger setting. If you ever encounter this warning when working with geometries in Dynamo, what you simply need to do is go to Dynamo Preferences and change this geometry scaling option over here. Click on the plus sign. So this specifies like how large you expect the geometries to be working with, so that Dynamo can set the accuracy accordingly. So if you are working with very large elements, you need to set it so it will change the precision. So now it has changed the precision to 0.0.01 to whatever this number is. This is pretty large numbers, 1 million it looks like. Yeah. So you can change it as you want depending upon how big geometry you want to be working with in Dynamo. Yeah. So now if I run it, you can see the warning has disappeared and it's no longer coming. So I can make it a little bit more larger. Yeah. And let me turn this into a solid. Extrude, again, what we were doing last day. Extrude as a solid. And since we are creating a ground plane, I would be giving it a negative distance, negative in the Z direction, minus say 5,000. Just so that it allows us to create a ground on which this is laid. Let me color it to make it easier to understand. Color palette. So again, using the color palette tool, and we will use geometric color by. Yeah. I can hide the preview of this. I don't need it. Yeah. So as you can see that the walkway that we have over here is half below the ground plane like this and half above it. Okay. So what to do? We need to make sure that we only have the path which is lying above the 0, 0 portion of the work plane. So what we'll simply do is we have the solid over here as the ground plane. We will do a solid subtraction. Okay. So for that, we will take all the solids, join them into a single one, which is the union command. If I type in solid union, yep, no, wrong command. Yes, solid by union. Yeah. So what we are gonna do is we are gonna feed in this list of 34 solids, which is each of these individual pieces of the walkway into a single one, is this, and it's gonna combine all of them into a single solid over here. So we can switch this off, and then we are simply gonna do a difference. Okay, which is a subtraction of one solid from another, of this solid with another solid. Okay, so the other solid will be the ground plane that we have, which is this one. And now we are gonna hide the preview of everything else we have generated apart from this last node, which is this one. Okay, so this is the only result we are seeing, as you can see highlighted over here. And you can see this has deducted out whatever element was below the plane of the ground. So if I go back to node and switch the ground plane all as well, switch to node view. So we have it. So we have deducted it and we have only the remaining portion of the walkway available to us. Okay. So we have reached a point like where the walkway is complete, but say we want to add something else, like say this is too boring and say we want the circle rectangles to be rotated as it moves along, like give it a spiral shape or something like that. So if we want to do and this can be any other changes, this is just something that I am using as an example how you can, like, the advantage of doing it like this instead of placing each and every element. If you are trying to design something like that is you can rotate the rectangle. Okay, so we have the geometry over here. We'll rotate it. Wait 1 second. Yep, this is a sub geometry. Yep, this one. So here we have created the rectangle. Now say we want to make it a little bit interesting and add a rotation to it. Okay, so rotate gives us a number of options. Since we want to rotate the geometries along the plane only on which it lies, we will select rotate. Sorry, yeah, this one, geometry.rotate, which will take the rectangle, which is the input, as the first input to it. The base plane will be the plane of the rectangle, which is this. And then it will be the degrees. So if I type in a number over here, say 15, connected over here. And then this will be the feeding geometry, which will be fed into the both this and into this. Okay, instead of the previous rectangle that we were using. If we run it now, you can see the entire walkway has rotated because all of the rectangles are rotated. If again, say we want to take it a step further and add a different rotation to each one of them, we'll do similar to what we did previously. Like we will need to create a range and fit it into a list of values. So you can copy the range over here. Yeah. So we have to specify a start number. Say we start at 0, like always. And the end, we can be flexible over here because we can have as many degrees of rotation as we want. Say we specify the step that we want it to be at a 15-degree interval. For the end, we can simply multiply it instead of specifying it manually. So what we can do is, and this will again depend upon the number of divisions we have, right? So it will depend on the number of rectangles that are there. So we have 34 rectangles over here. So we want to generate 34 iterations of like 34 different degrees at an interval of 15, like 15, 30, 45, and so on. Again, 180 and back. So what we'll simply do is we will use a list count instead of specifying hard coding the number of iterations that we want. A list count. Yep. We plug this in and then we can simply multiply this by the steps that we want to get the maximum that will be over there. Okay. If we run this, so we have a series of number which is like goes on till 510. Of course, it will rotate if it's rotating by 500, 360. So it will deduct and it will be the same shape. Okay. So here, instead of a single degree, we can plug this in. And this time, yeah, I think we should rearrange the nodes a bit at this point, getting a little cluttered over here. Yeah. Instead of using geometry, we can use rectangle also, because it's the same thing. The count will be the same. If there are 34 elements, there will be 34 geometries to rotate. So just to clean up the node layout a little bit. Yeah. So now if we run it, you can see every items now rotates a different degree. Okay. You can see it's still getting subtracted. Okay. This is a rectangular profile, but the solid is subtracted. Let me switch off the preview for the rectangle. And we can reduce the rotation. I think 15 is too much in this particular case. So let's reduce it to something like, say, 10. Maybe it will come a little better. Yep. So that's up to us. We can specify whatever angle we are familiar with that will control the spacing between the rotations. Okay. So once this is done, the shape is created. We want to like switch to node view, switch off everything, and we want to take it into Revit, right? Once we have generated whatever shape we want. Sorry. Once let me hide everything. Hide geometry preview. Yep. So we want the final result, which is this. We want to take this into Revit for further processing or whatever we want. Okay, currently till now we were only restricted to within Dynamo. So what we'll do over here is we'll create a direct shape. So this is the direct shape. For now, we will simply plug the solid into the geometry node and specify a category which we want to use. So in this case, I would be using, say, the wall category. Yep. This is a preview of this. If I switch off the preview. Yep. And now when I run the code, it should create the elements within Revit. Yep. Direct shape has been created. So now if I go into Revit, you can see I have the elements created as walls. Okay. This is a direct shaped elements, therefore you won't be able to edit anything. Okay. But you have the element. So, and if you want to change the color, here I apply the default Dynamo material to it also. But if you don't want to see it like this, okay, you want to see it like, don't like the transparency, all that, you can simply go to materials. And type in Dynamo. It will give you this. This is the default material that Dynamo uses. So we can change this or create a new one also. So in this particular case, I'm just gonna replace it with something else, just so that the preview is better. Yeah, you can see now it's a solid. Okay, so now it's a full Revit element and you can do anything else but it is obviously not parametric. If you want to change it, you again have to come back to Dynamo, make the necessary changes, and export it out again using the direct shape property. Yep, that's it for today. Any questions or any doubts?
Can we extract quantities from this model?
Yes. So the thing is, these are solid elements. Okay. So if you want, say, the solid volume, because you are constructing the entire geometry, say, what I would do is, say, if you want, what quantities do you want? Do you want the volume, surface area?
Like these walkways are like frames. Okay, so
Yeah.
can I get the length of each column and the
Yes.
beam portion? Can we get the
Yes.
length of that?
Yeah. So what you can do is, uh, if you run it, this will give you the volume. But over here, if you remember, we created it from curves only, right? Rectangle. So if I go and type in the curve length, search sometimes just doesn't work. Length. So if I put this over here, it will give me the length of each of the rectangles that are there. And then I can, so whatever geometry information you are getting, so that you have to get from here. Like you have to code the script in such a way that it takes these values and then you can write it to a parameter. Okay, like you can create a custom parameter and generate it from there. But if you create a schedule right away from Revit, it won't give you. So I can write the, like you can make a custom parameter and write it to it. Like I can use set parameter to write this value to a parameter every time this script runs. So
Okay, okay, yeah.
yeah, I will complete this. Any other questions if there are?
Hi, Saurabh.
Yeah.
I think basically Dynamo for this geometry and all, you are using it for architecture or for generative design or competition design. Do you
Yes.
have any idea that how we can use this for MEP sector? I know that if on MEP mostly we are using for documentation and some coordination purpose, but
I don't have a use case. Okay. Like I have not done it, but I can refer you to this. What I know, Evolve Lab did uh like uh what will I say, generative tool for HVAC layout. I can refer you to that. I have not
okay.
myself done it. Like
But Evolve Lab, I think it's a paid subscription basis thing. I think.
yeah, but if it can be done in, if they have done it, it must be possible to do it.
Yeah, this must be
Yeah.
possible. But the requirement for Python scripting and all that need to be done, right?
Yes, like I know this is there, but I
Yeah.
have not done it. Like if you say a use case, they have done this. Okay, so
Yes.
air terminals are placed and then they do the routing. So
Okay.
like I have not given it a try, but this is one use case when you say geometry and MEP that came to my mind. Okay,
Okay.
I will give you another use case. If you want to try, say you have face-based elements in Revit, right?
Yeah.
And they don't have a schedule level set,
Okay.
right? So how do you set the schedule level using Dynamo? If you
Okay.
like, you can try that. Like like two three things just top of my head that came. But as I said,
Yeah.
yeah, like
MEP services they are limited things, but yeah, we need to explore on it. I can understand.
So this is the two things that came to my head. Top of you can try another thing, which is say when we do pipe length optimization. Okay, like a pipe is not never like we can draw. I don't know whether I have the correct template on, but if we draw a 4, 5, 6 meters pipe, it's never bought together, right? It's bought in pieces.
No,
like
no, no, no,
say
no,
8 feet or
no,
something
no,
like that.
no. Actually, this is a generic family, so it will not cut into pieces. Okay.
So
Uh,
that's what I'm
uh,
saying. This
okay,
won't,
okay.
but you can try this. Like if you have,
Yeah,
say,
yeah. This one I have tried. This one I have tried.
huh,
This one I have created these things for
huh,
myself.
huh,
But the main thing I'm looking into something like uh, I have a floor plan, okay, like a 2D floor plan, and I want to use this generative design. Like architecture guys are using generative design to create their complex geometry and all. So I am looking something like that. I have a 2D plan and I have to optimize that design, and I want to create pipes or ducts using those PDFs. Is there any way
so
we can use Tree?
there may be ways. Okay, one of the examples which I showed you is Evolve Lab, and I think you're aware that Swap AI also does something similar.
Yeah.
Okay, but how much practical is it, or like this
Yeah,
looks cool?
that's the
Whether
thing.
but whether I can tell you I have not seen or ever done a practical project where we have used generative design in MEP and deliver something to the client. But
Yeah.
I am not. I don't know whether if somebody else has done it. Okay, these two things I have seen. I told you,
Hmm.
but I personally don't have like practically delivering it. But I also know that Swap does it. Like there are a lot of things that claim they do it, but
But
yeah,
the thing is something like that only, because
yeah,
the main purpose of mine to join in this live is to
yeah.
know the more insight about that how you guys are using this and how the MEP person will be beneficial from these things, and that's a great go from your side. Thank you.
Yeah. Thanks. Thanks.
Sir, I had a question.
Yeah.
When we update the geometry and
Yeah.
export is from
Yeah.
direct save by geometry,
Yeah.
the previous geometry gets deleted from the Revit.
Yes. If you have Dynamo open, it will get deleted from Revit. Yeah.
Yeah, but is there any possibilities to save the previous geometry?
Just save it and like you save it, close the script, and open it again. This is what I normally do. But this, if there is any like particular switch or button to keep the geometry, that I also have to check. But the thing is, if I close this geometry, like say I save this. Uh, like close Dynamo and save the file and run it again, okay,
Okay.
then it works. But just Google it. I can also like I remember this being a issue, but I did not explore much beyond it because that seemed to solve my problem. Like you understand, right? If I save it right now and run it again, it should not delete the geometry. Mm,
Yeah,
okay,
one thing only we can do is we can copy the overall things and keep it and freeze it, and another value we can add it to it.
yeah, but
That we
this
can
should
do.
not be there. If look,
Okay,
I
okay, got it.
what you're asking, I will also have to Google and answer this if there is any particular solution from Dynamo available or not. Stop deleting previous geometry. I have no idea whether any other solution exists. Uh,
Yeah,
there are
because
seems to be a
I
few
face
questions. Take a
a
look.
issue
Yeah,
that
yeah.
I have to create many directive
You're saying
geometries
some.
in a particular model from a particular script only.
Yeah.
I also do that and save the file and close the Dynamo. But anything other else from this?
So what you can like I would say whatever geometry you're creating, like if you're creating say multiple objects, okay, say three boxes or something like that, what I would do is, where is Dynamo? I would simply create a list of all solids together and create them once and for all. You understand what I'm saying? Like instead of
Okay.
closing the script and
Yeah,
doing it
yeah,
for
yeah.
every time, so yeah, this I remembered. There is something called element binding which it does. Okay, like it tracks whatever item it's going to create and it's updates. So what if you say you have multiple, you want to create say a rectangle of a number of sizes, right? Say which will get deleted every time you run it. So what I will do is do a simple example, plain. and say your requirement is to create a number of rectangles of the similar size and then create a direct shape. Say you want a 5 by 5 and then a 2 by 2 and so on. So, and like I'm just using this as an example. Of course, your it will be separate nodes. So what I will do is when I get this step, like say I have a number of nodes which are giving me the same thing. Okay. So okay, I have a sphere also for an example. Sphere by radius. Yeah. No, wrong node. Sphere by center point and radius. So if I have that also, so if I have creating a number of geometries, what I will simply do is let me move the center point. Say I give type in a 50. So I say have a scenario. I am assuming these are all separate scripts for you, which are giving you different 3D outputs. What I will do is before the direct shape step, instead of having 3 direct shape nodes over here, I will do a list, combine all of the 3 in. Flatten. So I have this list, and then I will simply run the direct shape again. Like this has been my solution, but I don't know whether this works for you, or else like we have to look your particular use case that you're doing and come up with a solution. Because
Okay, so
like
I will
there
try.
are, yeah, like you can share that if you are comfortable with exactly what you're trying to do, and then we can come up with a solution. But yeah, there must be a way. Like there are so many people working on this. Someone or the other will, I hope, have a solution to this. Yeah. Yeah. Anything else? Anyone has any other questions or else? Was this ever solved? I also have to read this. I have uh, exactly how to disconnect it. There's something for Civil 3D, so maybe we can do it for Revit also. But yeah, I don't have a ready-made answer for this. Yeah. Any other questions? If not, I think we will end the session for today. Yep. Yeah. Sagar, I think we can end it for today.
Yes, Saurav.
Yeah.
Yes.
Yep. Thanks. Thanks, everyone.
Okay.
Yeah.
Thanks, Saurav.